Hi, welcome to Advancement Tech. I'm just starting up the stream, so I will check some things to make sure things are going well. So, going to check the chat, make sure that's working, and make sure we're streaming okay. Welcome to Advancement Tech. We are doing, let me check here. Okay, so this is episode 9 of Advancement Tech and is what is DNS and how domains work. So just want to make sure we're keeping up, and it looks like we are. So welcome to Advancement Tech. We discuss technology as it relates to advancement offices, fundraising, and nonprofits. And we're talking about, as the title says here, what is DNS and how domains work. We are doing this live to give people an opportunity to chat while we're doing it. 4 p.m. Eastern Standard Time every Friday. I hope you're having a great Friday and plan to have a great weekend. I am monitoring the chat. You will and we're live on YouTube, so you will need a YouTube account in order to chat if you'd like. But I'm welcome to. You are welcome to ask questions, and I will try to answer them to the best of my ability. So I'm monitoring the chat, so feel free to post any questions you have as we go through the presentation. So welcome, thank you for attending. I'm going to mention a brief background about myself. We're going to have about 15 to 20 minutes of educational content and then a QA period where you can feel free to ask questions. All right, so who am I? Again, my name's Preston Jameson. I've worked at 2 different universities over the span of about 12 years. I oversaw development and advancement services there. I since then have founded a company and developed a product called Advancement Form, and that does online giving and event registration services. So the domain name system, or DNS, so that's what DNS stands for. And I went to Wikipedia to find the definition for this, and it basically says the domain name system, or DNS, is a hierarchical and decentralized naming system for computers, services, or other resources connected to the internet or a private network. So one of the main things is that it is hierarchical. So let's take a look at this, what it means by hierarchical. So if you look at, like I'm going to google.com here, it's hierarchical because you can actually place a dot at the end of the domain, and that is perfectly valid because that is considered the root domain. And then the next one over, the .com, is actually considered a top-level domain. And then the next Google is, you could kind of consider it the authoritative domain, or it's basically google.com is the domain name you would purchase, or mydomain.com, for example. So it's broken out into a hierarchy. So that's what it means there, because that's how it does name resolution. So if we go back, it's hierarchical and decentralized. So that means there's more than one server that is handling the domain name system to be able to be resilient in the case of failures with particular areas of the internet. And it's also can be on the internet, or you can also have your own private network that runs a name system within it. So that's also possible. And its most important job is to translate more readily memorized domain names to the numerical IP addresses needed for locating and identifying computer services and devices. So what does it mean about numerical IP addresses? Well, basically any device in an internet protocol network, that's what IP means, has a numerical address to be able to find it. And you'll actually see in some cases it is alphanumeric, but we'll take a look at this. So before we start talking about DNS and domains in general, what are IP addresses? So basically IP address stands for an internet protocol address. So every device essentially on the internet needs one to communicate. It's no different than an address you have and you send a mail to. It needs to go to some address. So similarly, for any computer to communicate on the internet, it has an IP address, and this is a numerical address. Now, we're going to discuss, it's called IPv4 or version 4, but this is how it typically looks. There's also version 6 that's an alphanumeric, and it's much longer. I won't talk about it in this presentation necessarily, but generally it's a series of 4 numbers ranging between 0 and 255 for each range. So this identifies a specific address. Now, anything on the internet that is going to communicate needs one of these addresses. There is also the concept of having your own internal network to be able to communicate, and it translates between back and forth using routers. Again, I'm not going to mention that here, but just keep in your mind that any device that's going to be communicating on the internet needs one of these addresses. Now, what domains allow us to do, and the DNS system allow us to use friendly names to identify these computers and devices on the internet or internal networks. So as opposed to, say, you wanted to go to Google to do a search, you wouldn't type in its numerical address. You would type in google.com, and DNS helps make it happen and sends you to where you want to go. So essentially, it's essential that the domain name system works on the internet. Otherwise, almost nothing will work. You know, if you send an email to myfriend@gmail.com or whatever organization they're a part of, that mail needs to use DNS to translate what, like gmail.com is, or your organization.org if you have a internet email address set up for it. All right, so let's look at this DNS resolution in action. Now, there's actually utility you can use on Windows or Mac or Linux system called NS lookup. So if you go to a command prompt, and I don't necessarily see one here, but that's all right, you can actually type NS lookup and some names. So let's take and it's basically does a name service lookup. So let's look at a few of these. So earlier I typed in, this is a command prompt in Windows, I typed NS lookup google.com. And what that does is it does a name service lookup for that name. It goes to the DNS system and asks, okay, what IP addresses are associated with it? And again, you see it returns multiple IP addresses that we can contact to be able to communicate with google.com. So our system chooses one of these and contacts it. Now, if you remember earlier, there was IP version 4, and that's what these addresses are. They're all numeric, a series of 4 numeric numbers between 0 and 255. This is actually you'll notice it's alphanumeric, and it is actually a IPv6 address. So that's what you're seeing here. Similarly, if I do a name service lookup for youtube.com, I get, again, back multiple IP addresses, and you'll normally see this for very high traffic services. They have multiple addresses that you can contact to use their service. But here's one that's associated with my organization called Advanced Prospects, and you'll see it just returns a single address because it doesn't, of course, get as much traffic as YouTube or Google, of course. So you can use this to actually look up and translate what an IP address is associated with a particular service. So this shows you that name translation in action. All right, so let's talk a little bit about the name resolution process. So how does this actually work? So first, when you type in like google.com, your computer checks locally. Now what I mean by locally, it checks in its own memory, in its own, there's a phrase called cache, what it's memorized, to see if it knows the IP address for a given domain you've entered. Now, if it doesn't find it, it then asks what's called a resolving name server. It could also be called a resolver or some other name server. It's basically the DNS server that you talk to ask questions of to be able to translate names into the IP addresses so your computer can actually talk to it, because your computer does use these IP addresses to talk to it. Now, when you contact this resolving name server, if it doesn't know what that name, the IP address it refers to, it then goes and asks what's known as the root domain server. Now, the root domain server references this dot that you can have at the end of the domain. So there's a domain server, a root domain server that's responsible for that. And it says, hey, do you know google.com? And there's a case where it may have forgotten what the IP address is, but it knows where to find the top-level domain DNS server. So if the root domain server doesn't know, it asks the correct top-level domain server. So in this case, it says, well, go ahead and contact the .com top-level domain server, and I know where it is. I don't know where google.com is, but I know where .com is, and they can help you there. So then the resolving name server, or the resolver, then goes and talks to the top-level domain server. And if it says, do you know google.com? And if it doesn't know google.com, it asks the authoritative domain server. So at this point, it asks a domain registry, hey, who are the authoritative name servers for google.com? And once it finds those out, it can then, that resolver can then go ahead and ask the authoritative name server for that domain name to get the proper IP address back. So with that, let's take a, now this was a lot of text, but let's actually look at this graphically for a second here. So here, like I called it a resolving name server or resolver. Here they're calling it a DNS iterator. So it's basically your computer is talking to this DNS iterator. The first thing it does is say, hey, do you know, for example, they're saying, where is www.wikipedia.org? And it asks the root name server. Again, that's the dot. And says, nope, try the top-level domain, and here is its IP address. And it sends it back to here. So the DNS iterator says, okay, so it contacts that top-level domain, which is the .org name server. And then it says, do you know where wikipedia.org is? And it says, no, go ahead and try the authoritative name server for that domain. And it says, okay, I now know that. So I'm going to then contact that authoritative name server for that domain. And it says, okay, well, it's at this IP address. So now it knows how to find wikipedia.org. Another representation of this is from royal.pingdom.com, where again, you have a computer and it's going to talk to a name server. Here they call it a recursive name server. You'll notice a lot of different terminology for it, but it's basically a DNS server that does the work of querying the domain name system to find a particular IP address. So this is all about translating a name into an IP address. So your computer talks to the name server. It checks the root name server again. So again, going to the root, then it references, okay, go to these top-level name servers to see if they know. And if not, they send you to the authoritative domain server for the domain you're interested in. Like here, they're testing ABC. They're trying to find www.abc.com. And eventually, through querying these different name servers, it finds the authoritative domain server, and then it knows where to find the IP address for this name, and it sends them to the proper address to find the service that it's interested in. Okay, so it also talked about a hierarchy that I was mentioning before, and the hierarchy kind of looks like this. So you have the root, which again is just the dot. If we go back to here, you know, there's a dot at the end. That is the root of the hierarchy, and that is there are root domain servers, and then there are multiple top-level domain servers. So for example, you have .com, which I'm sure you use very frequently. .org is used for nonprofit organizations. .edu for education type institutions. There are also country-based ones like UK, and then they've started adding even more top-level domains like TV. Like for example, we have a link to take you to the Advancement Tech Show, advtech.tv. So that is the .tv top level domain. And then spawning off from this are the authoritative DNS server. And again, there are thousands of these for particular domains. So for example, you have the google.com domain is under here. youtube.com is under here. If you had a myorg.org domain, it would be pointing to this one address. Now, and a very important point of this are the authoritative domain servers, because they are the ones that actually know where to find all the domain names that it manages. So let's look for an example. Let's look at example.com. Let's say you have this domain, example.com, where on this authoritative domain server, you configure it to know that, okay, maybe you have a web address and you say anyone going to this web address, you want to send them to your web server. So you actually would put the IP address of your web server or web service and have your domain point to that IP address. Or if you have an FTP server, which stands for a file transfer server, FTP means file transfer protocol, then you would point that domain name to the IP address of your FTP server. Or if you have multiple servers doing different responsibilities, like maybe you have a particular server in Dallas, you could even add even more subdomains to it and say there's an address, a domain name that translates to an address, IP address for star.dallas.example.com. All of these different name translations are input into the authoritative domain server that manages your domain. So how does this happen? So when a domain is registered by a registrar, so you buy a domain from GoDaddy or some other organization or VeriSign, when you buy that, on that domain at the registrar, you tell it what are the authoritative domain servers for this domain. So the registry knows what domain servers to contact to know where to find all of these domains. And then you configure the authoritative domains to find each of your domain names to IP address translations. All right, so let's actually talk through a few more domain examples. So for example, our main website is advancementforum.com. So that is the domain. And I shouldn't say website, but that is our main domain, advancementforum.com. Now we have a website at www.advancementforum.com. And what we've added is, this is called a subdomain, and it's www. So we've pointed this to our website. And we've actually pointed, if you happen to go to this domain in your browser, that you'll be taken to the website as well. Now our service that you can log into that actually manages the online giving and event registration is actually located at a separate subdomain called secure.advancementforum.com. Now, apart from this, we also offer custom subdomains, and every customer gets their own subdomains for our service. So again, we do an online giving and event registration service. So for example, if you have a nonprofit, you could name it mynonprofitname.advancementforum.com, and you could have forms that are using that IP address. Or you could have myorg.advancementforum.com or myschool.advancementforum.com. So we give you this custom subdomain. But we also allow custom domains as well. So for example, if you have the domain name myorg.org, you could have a subdomain called giving that would redirect to the Advancement Forum service to be able to show a set of your giving campaigns produced by Advancement Forum that you can just get to by using a friendly organization domain that you've set up. So this is how domain names can be set up and coordinated and managed, and how any service you have, you can add a domain name to be able to, or a subdomain as part of a full name to be able to find that given service and translate it into the proper server or device to contact. Okay, the last thing I wanted to mention here is to talk a brief bit about caching and TTL, because this is something you'll hear about. So as the DNS resolver is contacting different domain names, and even as your computer is talking to its DNS resolver, it's going to save certain information. So as I say here, most DNS queries are asking where a particular domain name translates to in terms of an IP address. It saves the results for a period of time, and that's called caching. It's basically saving the results for a period of time in its memory. Now, closely related to this is the term TTL, where it basically is an acronym for time to live. In other words, how long should we keep this result memorized? So, for example, if you have it set to 5 minutes for a particular domain name, it'll remember that for 5 minutes. So your computer or maybe your DNS server doesn't have to go through the whole process of ask the root domain, ask the top level domain, ask the authoritative domain server. If you're constantly doing queries on your computer, it'll remember that for 5 minutes, or maybe you can make it 60 minutes or a day. It's basically how short you set it is how often it will need to refresh its memory, because it keeps it memorized for that long. And again, in addition to the DNS servers remembering something, also the clients that use it, so your operating system will also remember it based upon its cache as well. All right, so that is pretty much what DNS is and how domains work. So at this point, I welcome any questions you have. And while I see if there's anything in the chat, I will go ahead and talk about upcoming shows. So I'm still thinking about what would be the best thing to do next week. It may be about cookies as they relate to websites. It may be about securing DNS, because there's DNS security is very important, because essentially if your DNS is not secured, you could easily type in a name and actually be redirected somewhere else you didn't intend. So security with regards to DNS is important. So I would like to hear from you. Feel free to type in the chat or leave a comment in this video about what you would like to hear about in terms of upcoming shows. So I do read this, and I can check them out and plan for what the future shows might be. We do these live shows every Friday at 4 p.m. Eastern Standard Time. So I welcome to see you at a future live show. All right, I don't see any questions in the chat, so I think we're pretty much done for this week. Again, if you want to find out more about the Advancement Tech Show and want to receive notifications of future shows, be sure to visit advtech.tv, and you can sign up to receive email notifications. Also, if you're watching on YouTube, you are welcome to subscribe and like this video, because it does help us grow our audience. And again, I encourage you to leave a comment about what you would most like to see in terms of technology discussions on future live shows on Friday. And with that, I think we'll close it out, and I will see you next Friday.